This is lesson 4.6, college algebra, page number 410, applications and models, growth and decay, compound interest. Alright, so in this section, it's pretty much just summing up what we've done in this entire chapter 4 using applications or story problems. We're going to look at a couple to do with population growth, and then we're going to do some with interest, and then we'll jump into limited growth and exponential decay. So 4 different sections there, and we'll see what we can do to make these as simple as possible. But we do have, when it comes to population growth, a general formula. Population given a certain amount of time is going to equal the original population, that's a 0 there, times E with the exponent of kt, and k must be bigger than 0. So this is a way that you can look and see the growth of population of people, bacteria, money, that kind of thing. So it's not really that difficult to do. It's just kind of going through each of these and making sure you've got it figured out. So probably the one you don't know is the K. K is the exponential growth rate, and we'll be looking at that one in a little bit. T is the time. P of O is our initial population. P of O would be the population at time 0, so the one they gave you to get started with. And then your P of T here is the population after a given amount of time. So in order to find the population out of a given amount of time, we have to take our initial population. We have to put the exponent of growth rate times time onto the constant E, and that exponential growth rate has to be bigger than 0. Okay, so our population would be increasing. Okay, so if you look at example 1, it gives the population of China, and it has some things it wants us to find. So it gives us a population 1 year, and maybe it wants to find out when that population will double, what year it will double, or how much that population will increase over the next 10 years, that kind of thing. So we're going to be using this population growth function in order to do that. So it says in 2005 the population of China was about 1.306 billion. Okay, so just to kind of give you an idea, the current population on Earth is about 7 billion. So this was 11 years ago. So there's a big chunk of the population is in China. The exponential growth rate was 0.6% per year. 0.6% per year. So that's my K. So part A says find the exponential growth function, which means what they want us to do is they want us to find this equation right here with as much information as they've given us. So we can rewrite that. That's part A, as population given a certain amount of time is going to be my initial population, 1.306 E. We have our K, and K is written as 0.6%. In order to change that, we have to take the percent sign off. So 0.6, we have to move that decimal place over 2 in order to change 6% to a decimal. So that's 0.006 times our time, which we don't know. Okay, so that's the exponential growth function that we're going to be using for our figuring. Alright, so B, they want us to estimate the population in 2008. Okay, shouldn't be terribly difficult because we're looking at the population 3 years from 2005. So that's what the t is how many years from our initial or original to the point that we're looking at. So 2005 to 2008. And that's going to be our 1.306 E 0.006, and again we put our 3 there, and we do our math. And so first of all, what I'd want to do is multiply these two, and when you multiply 0.006 times 3, you get 0.018. So I'm going to erase this and just put 0.018. Okay, so then I can take my calculator and do my e to the 0.018 and take that and multiply it by 1.306, and I get for an answer 1.33 billion. Okay, so it grew a little bit in those 3 years. Started out 1.306, and 3 years later 1.33. Okay, C asks me, after how long will the population be double? Okay, so we're looking for a time where my population is 2 times my original population right here. So I want to find out when this is double. Okay, when we want to find out when something is double, we're looking for what is called the doubling time. How much time for it to double? So what we want to do is we want to find out when that population is 2.612, because that's 2 times this. Okay, so all we have to do is instead of this equation right here being written this way, we know what our population per time is. Our population that we're looking for is 2.612. And we also know our original population, 1.306. And we have our E. And then we've got our 0.006 to the t power. Because again, t is what we're looking for. They're asking you to come up with the time when our population doubles. So that gives us that as our equation. Alright, so that being the case, let's see what we can do with that. So we have this entire equation here to solve. So that is written just like we need it. So what do we do with this thing? Well, first of all, we're going to do some basic algebra. We're going to try to isolate the t is what we're looking at doing, because that's what we're solving. So we can't get rid of any of this because it's all connected to the t, but we can get rid of this because this is being multiplied. So if I divide both sides by 1.306, that goes away, and 2.612 divided by 1.306 here is 2, and it will always be 2 no matter what you use, because we doubled this. Remember, from the original we found this, we did the doubling time, so this will always be twice this, so when we divide we'll always get our 2 back. So 2 equals e to the 0.006 t. So if you remember from the last section, when you're given something like this, you take the ln of both sides. So we're going to take the ln of 2 equals the ln of e to the 0.006 t, And remember what we said about that, that goes away, and it just equals that on that side. So we get ln of 2 equals 0.006 t. Then we divide, and that goes away. So ln of 2 divided by 0.006, you do that on your calculator, and the population of China will double in about 116 years. Okay?